Hello, hello.
Hello. कर सकते हैं start? Okay. Uh, a very good evening to all of you. My name is Monit Kapoor. I am assistant professor here at University of Petroleum and Energy Studies in Center for Information Technology. Um, I have close to 10 years of industry experience and close to 9 to 10 years of experience of teaching. Since last 4 years, I have been working with University of Petroleum and Energy Studies in Center for Information Technology, and my qualifications are there indicated on the slides. Uh, um, Today's topic for webinar is the cloud computing. I've kept the name as cloud computing demystified. And as you can see in the picture at the top, there are various devices which are getting connected to that virtual cloud, which offers a plethora of services over there. So we'll be trying to figure out how these things happen, and I'll be my focus will be to give you a primer of what to expect when you actually go in to take a course of B.Tech in computer science engineering with specialization in cloud computing. So straight away I will jump to the agenda for today's webinar. There are certain myths about cloud computing, so I'll be discussing upon them for a brief while. Then we'll be going straight away to certain jargon, certain terminologies belonging to the cloud environment. And then the things will get more technical where we'll be discussing the delivery models, the deployment models, what are the benefits that companies get to when they go on to adopt cloud computing technologies. Then what are the possible set of recruiters that you need to look at, uh, and the various job profiles that we get, and also there are certain slides at the end about that what industry speaks about cloud computing technology in present times we live in, which would be followed up with the question and answer session. So that was about the agenda. Now coming straight away to um the myth that we call as cloud computing. Uh, Cloud computing is actually surrounded by a lot many myths around the world. Recently, there was a very funny-looking video which was being shared on various social medias, where people were talking about whether if weather goes wrong, whether cloud computing is going to work or not, and it was a very intelligent person who was actually speaking in those terms. So it is none of those. See, these myths which are indicated in these cartoons, I've taken them from cartoon stock. Uh, this cloud help desk, it is suggesting to the customer though that ma'am, you're not losing your any of your data because it's raining. And on the other side, you got IT manager who's asking his IT work person who has actually tied the compact disc or the discs which are carrying data, and they're sending it via balloons to the cloud. So it is not at all like that. It is much technical, and it has got nothing to do with it's got nothing to do with the environment or something like that. It is, in fact, it is a synonym with computer science engineering these days. Maybe 5 years down the line, cloud computing would be termed in the same manner as we would be terming computer science engineering. So that is where this whole technology paradigm is going towards. So that was a little bit about the myths that we need to break at the start and to make the environment a little light. Uh, Next is like what is actually cloud computing? Technically speaking, when you go on and start searching for definitions of cloud computing, um, there are various definitions you will actually go on to encounter. Uh, Before actually I define you cloud computing, I would start with a very common example. We all have electricity connections in our houses. When we use the electricity, we got a electricity meter which is placed just outside the premises of our houses. That electricity meter it belongs to the electricity transmission companies, and they transmit electricity via those poles and cables that land at our house. And we all consume electricity in our house, and whatsoever we have used, that is what we actually go on to pay for. Having said that, yes, that is how we use electricity, but we need to ask a simple questions to ourselves, that do we need to actually own the substation or the dam to consume that electricity? The answer to this question, once we put it to ourselves, is definitely a big no. No, we do not need to own the substation or the dam behind where the electricity is actually being produced. So actually we are consuming electricity as a service. So that is precisely what we need to replicate in computer science engineering when we want to understand this term cloud computing. There are different perceptions and ideas which are prevalent worldwide. Uh, the first definition that I have listed in this slide over here is that cloud computing is actually a style of computing where massively scalable IT enabled capabilities are delivered as a service, in quotes I put it, to external customers using internet technologies. See, internet was there, it was prevalent worldwide since many years. Only thing was that people used to have all the IT resources in their premises, whereas cloud computing is exactly the opposite. Here, the IT capabilities, when we talk about IT capabilities, it would be computing, it would be network, it would be database. So these would be the different IT capabilities, and we need to scale them up. Scalability is that phenomena where we assume that the system is going to behave in the same manner, where if we have got a lesser number of users who are using the same system, or we got more number of users who are using the same system, the system's performance should not degrade. That is what we call as a scalable system. For example, we see that during peak hours, uh, the speed that we get over our internet modem, it gets dropped a little bit, or it might drop a huge bit. So if that is happening, then we say the network is not scalable. So similarly, there are other IT enabled capabilities which can be delivered as a service by using this cloud computing. So there would be one set of resources, or there will be multiple sets of similar IT capable resources which would be actually kept by the cloud computing services providers, and they would be delivered to the end target customers as a service over the internet. So internet is a mandatory to consume the services over cloud computing. That is one way I would put it. And then the second definition which is there is that cloud computing is the delivery of computing as a service rather than a product, whereby shared resources, softwares, and informations are provided to computers and other devices as metered service over a network, typically internet. So it's not that we need, in certain cases, we might not actually need internet to use the cloud computing products, which would be, or cloud computing services, which would be delivered to the end customer. Cloud computing can be delivered without internet also. So internet is mandatory. Most of the cloud services would be delivered through the internet, but there would be certain sets of services where internet might not be delivered. So based upon this, we actually go on to understand this phenomena of cloud computing. Now this next slide that I have put up for you people over here is that there are certain jargons belonging to this cloud computing environment. Um, these jargons are virtualization, as our computer engineering branch that we run over here in University of Petroleum and Energy Studies. It also says B.Tech in computer science engineering with specialization in virtualization technology and cloud computing. So I would briefly explain you about what is virtualization. Then these are certain terms: SaaS, we call it as SaaS, PaaS, PaaS, IaaS, IaaS, and then star AAS, where star means anything that we can offer over cloud. So virtualization is that piece of technology where, to put simply, we would have one resource which would be actually shared among multiple users during the same point of time or different point in time. So when we say virtualization technology would be putting that IT resource that we are going to consume over the internet, available for multiple users simultaneously. But then how do we actually make it available to the different users simultaneously? To explain that, there is a very simple example which I would quote over here, that our computer, normal desktop PCs that we use these days, are carrying multiple cores of CPUs, and each of core is having compute power of in gigahertz. So when we multiply those cores with those gigahertz, we got huge computational power on our computers. And we all use our computers in various ways. We might actually press in for one download on our PC, and then we go on to check our email while that download is happening at the back end. So our computer is actually being put to multiple uses at that time. Multiple usages are being carried out by our computer. So we are actually virtualizing our hardware at that time for various browser based applications or otherwise desktop applications that we might be running on our PC. We might be actually listening to the music via our headphones. So these are, for example, right now I am actually broadcasting a presentation. My camera is on, my network port is enabled, and my mic is on. So I'm doing so many tasks through my own PC. So this is how we actually understand this virtualization technology. Now, this virtualization technology would actually be a representative of using the same resource over multiple users at the same time. Then these terms come: software as a service, platform as a service, infrastructure as a service, or anything as a service. Now, these are different terminologies which are actually handled in the later parts of the slides. The SaaS, PaaS, IaaS, these terms are encountered these days in day-to-day life. So I'll be elaborating upon these terms in my future slides. And in this slide that is next, the various delivery models, they have been presented over here. Uh, the various delivery models which were discussed in the previous slide, infrastructure as a service, or I'm just rolling the mouse at those points, infrastructure as a service, platform as a service, or software as a service. Now, infrastructure as a service, as you see, now this is actually the entire stack of cloud solutions. At the bottom, we have got storage or the data center, which might be exhibiting itself in mechanical and electrical devices. Typically, the hard disks or the cylinders which are carrying the information that we consume over the cloud, that is at the bottom. And then at the on the top of that storage, we actually place the network. That network then gets connected to the actual physical servers. As you can see certain company logos over there, so those are the companies which create those kind of servers which can actually work on these networks, and they can actually exploit the resources of the data centers. And then these servers, they are fitted with the virtualization layer that I was just talking to you, the virtualization example that I was giving to you. Here, in this case, as you can see, the virtualization layer is given by VMware or XCN. So these are certain virtualization softwares. These virtualization softwares would actually do what? They would actually break the machine into various virtual machines. One single machine would actually be broken up into various virtual machines, and each of these virtual machines would be used to satisfy the needs of different customers or to satisfy the different business needs of the cloud. Until starting from this data center, network, physical layer, and up till this virtualization layer, we talk about infrastructure as a service. That is what we call as infrastructure as a service. Then we go to the next level. On these virtual machines, we might actually go on to deploy a Windows operating system or a Linux operating system. So these are two predominant operating systems which are currently being used in market. So that's why those examples are there. There might be some other operating systems which would be actually supported by the virtual machines. So then on these Windows virtual machines or Linux virtual machine, we actually place the various infrastructure softwares that you can see over there: Java, MySQL, Oracle, SQL Server, Google Apps. So these are various uh, infrastructure softwares that we actually place on these Linux virtual boxes. Till this far, we call the services as platform as a service. And then once we have deployed our Java, we have deployed our MySQL or Oracle database, then we build applications out of that. The normal applications that we see in our day-to-day life. We all do video games over internet. We all do emails. We all do different kinds of stuffs. We visit internet every day. We go to our bank sites. We do everything. So those are the hosted application softwares which are running on certain domains. So those softwares are those the once we keep them on the top of these Windows machines, which we have actually developed using these Java technologies, Oracle technologies, SQL Server technologies. We call this entire whole piece of services as software as a service. So if you look at carefully, to consume a software as a service, to consume a software as a service, we would definitely need a platform underneath it. We would definitely need a IT infrastructure under it. If we want to consume platform as a service as a target audience, we want to build our own software using the cloud services. Infrastructure is a minimum. We would need an operating system. We would need those application development tools. Application development tools would be your typical programming languages like Oracle or Java or MySQL, along those stuffs. And if we do not want to own the platform, we just want to own the infrastructure, and we just want to have a virtual machine at our disposal, By a virtual machine, I would say I would classify a industrial strength virtual machine which has, let's say, 200 terabytes of data center storage, and it has got a network connectivity with that particular storage, let's say to the tune of 20 Gbps, and then it has got 50 cores of 2.6 gigahertz processor, let's say, and then on the top of it, it has got 20 different virtual machines which are there. So this is what we would actually classify typically as a infrastructure as a service. So these are three terms which were listed in the previous slide: infrastructure as a service, platform as a service, and software as a service. And these services are actually offered to the people or to the client devices using the interconnecting network. So there is one piece of network which would actually connect to these services, and then there is a different piece of network which is actually connecting to the data centers services, which actually placed in between the physical servers and the data center. So you and me, when you are actually accessing our cloud-based services or cloud-based APIs that we are actually present, we would be actually connecting it through the interconnecting network. Whereas when we are actually deploying something while sitting on the top of infrastructure as a service, then we would be actually using the networks and the firewalls which are present between the data center and the physical servers. And we would be actually deploying our applications while sitting on the top of the virtualization layer using those Windows and Oracles and Javas and ASP.NETs. So to summarize this, on the right side, what has just appeared, that what this cloud computing actually offers to us. Now, cloud computing, it offers a new way to implement IT infrastructures. How does that actually goes on to do? By combining the infrastructure, software, and associated processes, and offering it as a service that may be availed on an on-demand basis. That is what I started with, that we do not need to own the entire piece of do we need to always keep our bulbs on in our houses? As and when we need electricity, we'll simply switch our LED or LCD light on, and our room is illuminated. Similarly, here also the infrastructure and the software and the associated processes for of provisioning those services and the softwares, they would be actually bundled, and they will be made available to the target customer on an on-demand basis. Now, cloud computing provides a ready-made infrastructure which is maintained by cloud services provider. So what is this cloud services provider? That is where we are progressing to. As it is mentioned in the bottom, the SPI model they would be following. This SPI model, software, platform, or infrastructure, this would be relying on the delivery models that I have just discussed to you. The software would be based upon software as a service. The platform computing model would be dependent on the platform as a service. And similarly, infrastructure as a service model would be based upon the infrastructure model that a cloud service provider would be maintaining. So that is how we actually simplify to understand what is cloud computing and what are the various delivery models of cloud computing. Then the next slide is about cloud service providers. Now these cloud service providers uh, are those entities in this busy cloud market arena which are actually providing you the cloud services. When I say you, I mean the target audience. The target audience, as you can see in the middle of this diagram of this picture, the target audience can be a business user or a consumer. It can be a technical IT community. So it all depends who is actually consuming cloud service providers. So if you can see over here, cloud computing services are actually consumed by the IT industry itself. And cloud computing services are being used by common people, normal people who are working in day-to-day lives, who might be a customer of a bank, who might be a customer of an emailing solution provider, who might be a customer of a retailing portal, or who might be customer of a online cab booking agency like Ola, all those things. So this is how we actually go on to understand. Now, as you can see, at the top is provided software as a service. Software as a service, here a application software or a service would be actually provided to the target business user or the consumer. And the companies which are actually dealing in this space would be Salesforce, NetSuite, Zoho, Zimbra, Office Life, Concur, Talio. So these are the companies which are actually dealing in the space of business user or consumer and providing dealing the space of software as a service and providing those services to the business user or the consumer. I will give you a very common example of this office live of this software as a service. We all go and work on Google Docs. Many times you might have actually done it as a part of sharing certain piece of information in your classroom with your other peers. So that is one very common example of software as a service. Software, now these softwares, business users on the other side, we all use on day-to-day basis, we are using certain applications on our mobile devices. Those mobile devices are actually using certain piece of software which actually goes on to connect to the cloud services. Now just imagine number of people hitting onto an e-commerce or a retailing portal on the say on the pre-Diwali or some pre-Christmas sales offer. At those times, different people would be actually coming into the same system and looking for same products. And often we see that those products actually go offline also, and all the products are sold within a very fast period of time. So that means more number of people were actually visiting those systems. They were pressing for those services, and people were actually consuming those services. So that is one way to look at it. Then, from banking perspective, I'll give you a very common example. Uh, we know in India the pay cycles, they would be people would be getting their salaries from their potential from the employer from where they are working, from let's say from a date of 30th in the month to let's say 6th or 7th in the next month. So that is where more people would be going on to their banking sites. So they would be using those banking services. So that is one example where a business user goes on to use a software as a service. And another very common example that we use in our day-to-day life is the common social network or the Facebooks that we use. That is also one more example of software as a service. Then comes the platform as a service. This is something that is actually consumed by technical IT community. And various companies which are dealing in providing platform as a service in present times, those are Google Apps, Engine, and then Force.com, Microsoft Azure. So these are certain companies which actually provide platform as a service, where they would actually provide you the data center, they would provide you the firewall over the top of the data center, then they would actually provide you the virtualization piece, and then on the top of that they will give you licensed softwares, as well as they will give you the various tools and technologies to develop your softwares over cloud, where you don't have to actually bother for the licenses or something like that. And then at the bottom is the technical IT community actually goes on to consume infrastructure as a service also, where companies would say, okay, I have got my own licenses of Java, Oracle, and all those. Java is in fact free source, so I have got my own software licenses for Oracle, and I will actually use it with my Java software that I have, and I would only need connection to a virtual machine, and I have got my own operating system through which actually I'm going to connect to the infrastructure at the bottom, and then we actually go on to deploy services or to develop certain products based upon sitting on the top of these IT infrastructures. And these IT infrastructure is actually provided by Amazon, Rackspace, EMC, Sun. So these are certain companies in the present times which actually go on to provide you the various services over the infrastructure. Now going further, the next slide is about the cloud service providers. Next few slides I look forward to cover that. The first slide is about Salesforce. As you can see, this is a snapshot that I have taken from their web page. Now, I have actually particularly clicked on the products tab. As you can see, Salesforce, they provide you with the sales cloud, service cloud, marketing cloud, app cloud, analytic cloud, community cloud. So these are the various products that they actually go on to provide to the various, and they have also got an app cloud. So if there is a mobile app, that is also where they actually come. So what actually Salesforce gives to its users, it will actually develop certain products which when be directly used inside a piece of software, and they would be actually having their own platform at the bottom, and they would be having their own infrastructure at the bottom, and those applications would actually scale up based upon the demands of the customers which are present to use that piece of software at any given point in time. So that is about how Salesforce goes on to provide the SaaS delivery model. The SaaS delivery model stands for software as a service. Then we come to Google Apps. Google Apps is an example of platform as a service. There are different categories of apps which actually Google goes on to provide to its target customers. Uh, Google Apps for business, we have got Google Apps for education, we have got Google Apps for government. As a matter of fact, in University of Petroleum and Energy Studies, we actually use these Google Apps for education for our day-to-day business of running the education, where we actually deploy these applications for the benefit of our students. We also use the Google mailing solution to run our corporate emailing solution. So there are so many things which actually we also use, and likewise there are many other companies which actually use the various Google apps. You can visit the link which is provided at the bottom of the presentation to go and have a look at various services that Google offers over cloud. And in this slide, I have detailed you that who are actually consumers of these Google apps. There might be small businesses, there might be medium businesses, there might be enterprises which would be using these Google apps. And what are these Google apps? There might be a business Gmail, there might be a business calendar, Google Docs. Google Docs, yes, for a limited use, we can do certain tasks in Google Docs. But there are certain privileges, or there are certain things that if we want to do it inside Google Docs, they simply don't allow us through our normal Gmail accounts. So for that, we have to actually go and take a license for those Google apps, and then we can actually do multiple sites, multiple things over these Google Docs. And Google Sites is one another app which is actually being hugely exploited in these times by small and medium enterprises, where they actually get their sites customized so that they start appearing in Google search engines, and so that more people can actually come and they can use the products, or they can come and consume the products which are being provided by those sites. Those sites might be merchandising sites, those sites might be selling some peripherals of computers, they might be anything. So they actually go on and use the service of Google Sites. And then Google Cloud Connect and Google Apps Marketplace. Google Apps Marketplace is one more place where all the mobile apps provider, they actually go on to release, if one has to release their Android application, they actually have to go and supply it um, on the, you can actually go on and supply it to the various people worldwide using Google Apps Marketplace. You can actually go on to actually monetize your app also. Of course, Google would take some cut of the revenue, but that does not makes much of a difference if your application is a hugely selling one. For example, let's take example of a Candy Crush app or a WhatsApp app. So people are actually going on and consuming those applications day in and day out. So that is about Google Apps and platform as a service. Now we come to infrastructure as a service. Infrastructure as a service, the companies are like Amazon, Rackspace, and there are a few others. Even Google, sometimes Google is also providing infrastructure at some places. IBM is one which actually deals in infrastructure as a service. So there are many companies which actually provide infrastructure. So uh, Dell is one. So there are various companies which actually EMC Square is one. So these are various companies. So I have taken here example of Amazon. Amazon Web Services. What they actually see, if you can see the listing of the products and the solutions in this in this particular slide, they actually provide you compute. When we say compute, that means they would actually allocate you certain amount of cores of CPU if you want to run your day-to-day business, and those would be consumed by you as a target audience. And they actually go on to provide you storage. They give you the database management services over web. They even provide you networking services over web. So if you got certain networking aspects that you don't want to own up the network elements to serve your customers worldwide, you can very well rent it from Amazon, and you can run your business. You don't need to actually go and physically deploy some kind of a router at distant location. You can very well use the Amazon's networking services. And similarly, there are certain other products like web applications, big data, and high performance computing. So these are certain other areas which actually Amazon, this high performance computing is one another major area where IaaS service providers play a huge role. I'll just give you one example that there are various research problems which are there in biotechnology area, or in the area of high-end research belonging to medicines that we consume in day-to-day life, that is pharmaceutical industry. So now these industries, biotechnology or pharmaceutical industry, their core areas is to do research and development of newer molecules so that it can result in better health management of its target customers, the people who are going to buy those medicines. But when they actually go on to deploy to test these medicines, they have to run these test runs on huge piece of computations. So companies actually they don't have to purchase those high-end computing architectures. They would actually simply get that HPC from that HPC. When I say HPC, I mean high performance computing setup from these companies like Amazon's, and they will simply deploy their application on those high performance computing architectures, and they will run it on that high performance computing architecture for maybe few hours, and then they get the result out. So they don't need these high performance computing architectures. Similarly, there are many experiments belonging to the space research, geoinformatics area. There are various areas for which you actually need high-end metallurgy, nanotechnology. So these are various areas which actually need the services of high-performance computing platform. So for this high performance computing platform, you actually, as in an educational institution also, like for us or different various other institutions where a lot of research is happening in India or worldwide, they don't actually own the high performance computing platform. They will simply rent it from some high performance computing provider, and they will run their trials on that piece of computing, and simply they will get the results, and they will use those results for their own benefits. So this is where, and then also another huge services that we use in our day-to-day lives. We all use actually cloud is all around us. Cloud services all around us. We don't actually sometimes appreciate those. For example, we all have Facebook accounts, and we post different kinds of pictures on different. We upload different videos on that. Have you actually bothered to check where those things go? Where those contents that we actually post on the web through these social media platforms, where those things go? So once we actually go on and log into our Facebook account, we see everything in one particular window. We click on the tab of pictures uploaded by me, and we see all the pictures which have been uploaded by us as a user. But if you ask me, those pictures are spread in different data centers that Facebook runs. It's not that only one, wheresoever Facebook is headquartered in USA, that entire data is available over there. Facebook would actually have its data centers at various places worldwide, and they would actually use those data centers to give you a real time experience of clubbing all those contents that you have actually uploaded within one console. So that is how we actually visualize the infrastructure services. Though, of course, we are actually consuming those infrastructure services over the Facebook.com platform. So that is how we actually understand these services, and this is what we actually read, or that is the purpose of our study when we actually go on to study cloud computing as a discipline. Then Microsoft is another major player in the cloud computing environment, and they have got this product Microsoft Azure, and it provides different kinds of applications. As you can see in the SaaS stable, it provides compute, storage, database management, multi-leniency, and it also works in market space. But Microsoft Azure is a proprietary kind of a solution, and one has to. Whereas on the converse side, I have not kept that a slide in my this presentation, but OpenStack is one solution which is exactly opposite of this Microsoft Azure, and it is a open source way of providing services over the cloud. So Microsoft Azure, when it wants to provide platform as a service to the enterprises, it would provide it through the compute, database management, identity, service bus, business analytics, and all those things. So this is one another area. When I say enterprise, we talk about top-notch IT companies which would consume platform as a service, or there would be another set of customers which would be using platform as a service in the enterprise. Those are non-IT companies. For example, let's say there is some paints and dyes company. It wants, for example, there are these various house, we all paint our houses with different colors. So these days we can actually go on and check how our wall is going to look like while we visit their portal. So all those services that we are using at that time for that enterprise, like Asian Paints or Nerolac, all those companies, they would be actually using at the back end. There would be certain cloud-based solution because you are doing image processing application at the back end. So that is one way to look at it. And then last piece that is very important in these days, mobile. Mobile, that is another area of application of Azure where actually you can actually go on to you can go on to develop mobile applications for content delivery, for identity, traffic management, and of course we can provide compute power using a mobile platform. That we can also provide storage power using mobile platforms. So that is about the various delivery models. So what we have covered till this far is what actually is cloud computing. We have just went on to define that, and we have discussed about the various terminology, the jargons that surround this cloud computing environment, which is infrastructure as a service, platform as a service, and software as a service. So we have tried to break up that entire stack of cloud solutions, how actually it pans out in the industry and how industry understands it in modern times. So I hope it makes a certain amount of sense to you. And then we discussed about various cloud service provider companies and how they actually offer these services and how we are actually seeing these services in our day-to-day life. And then this is the present slide where we talk about the deployment models, the various deployment models which are famously known are private cloud, public cloud, community cloud, and on the top of it as we have got a hybrid cloud. I will briefly explain you about these private cloud, public cloud, and community cloud. Uh, First, we will speak about public cloud. Public cloud is that set of cloud services which is available to everyone. When we say everyone, it means all the services inside this public cloud. It might be platform, it might be software, it might be infrastructure. Those would be made available to the entire user of entire internet space or the entire networking space. Here licenses won't be asked for, here nothing has to be paid, and everything would be, there would be a lesser level of security. That is what would be the technical nature of public cloud. Then going further, we have on the other side we have got private cloud. Private cloud is something that would belong to an individual or to a certain organization, and the services would be available inside the premises of those that organization. When I say premises, I'm talking about the virtual space, but those services would be available to the people who belong to that private organization. For example, if you have ever happen to visit our university, we have got our own internal systems where the students can actually go on to check their attendance. If some faculty has shared certain content, they can go on to check that on a particular portal over there. So those are certain services which actually typically qualify as private cloud, because those services are available only to the faculty pool and to the students who belong to University of Petroleum and Energy Studies. Whereas public cloud would be those services that we typically get from our government portals, from the Indian government website, gov.in. So there are certain public cloud services that we get over there, where we can actually go on to check how many, what are the various places where our officers are sitting, or what are their email IDs. All those services are actually hosted on public cloud, and it is available for everyone. And sometimes we actually have to mingle these private services and public services, and we may actually go on to make it as a hybrid cloud. And community cloud is somewhere in between public cloud and private cloud, where security can take a miss for certain private cloud concerns, or where certain amount of private cloud users can actually go on to consume the service of public cloud simultaneously, so on and so forth. So these are certain, but uh, to segregate them into distinct parts, these deployment models would be private cloud and public cloud, and rest of those cloud deployment models, they would be actually falling somewhere in between the realms of private cloud and public cloud. Hybrid cloud would be something which is a combination of a public cloud and a private cloud and a community cloud, where all these applications which belong to public cloud, community cloud, and private cloud, they would be actually merging in, and that is what we call as a hybrid cloud. And these deployment models, they rely on these reference models. There is a physical model at the bottom where servers clusters are there. Then there is a virtual, where our virtualization softwares where they work, and then we instantiate them using the connectivity, and we configure them, and we actually deploy the various virtual appliances, and then further we actually provide the control to the participants in the system, where they go on to meet the service level agreements which has been mentioned over there, timing to meet the SLAs, and then we transform it using the data encryption, because security is a concern in cloud computing technology. And further we do batch applications for those, or high performance computing we perform. And finally we have got the IT functionality at the top, which uses all the reference layers at the bottom. It's a little technical to understand. This presentation would be there on the YouTube, so you can visit back again and you can have again a look at this. Is these different layers are actually part of the study. If you ask me, at University of Petroleum and Energy Studies, there would be courses at all these different levels when we actually take a computer science engineering course at University of Petroleum and Energy Studies. Next slide is about benefits of adopting cloud computing. I'll fastly run through these benefits of cloud computing. Uh, the various benefits are dynamic scaling, we can share the resources, pay as you go model, the mobility is increased, there is no capex. When we say capex, it means capital expenditure. Companies don't have to buy those data centers, they don't have to buy those servers, they don't have to buy those software licenses to do their work. And availability is very very high when we actually go on and adopt cloud computing. It is very easy to manage, or we can rather ask the cloud solution providers to manage the things for us as a end user. We might be a IT user or we might be a business consumer user, and it is environment friendly because we don't have to have multiple compute powers to run the different tasks. We can use the same compute powers, so that means lesser energy is needed to run those computation centers, and less deployment time is something indicative of deploy as you go, because as and when we need, we can ask for a cloud services on the go, and once we don't need it, we can simply release it. So on one end we pay only for as much as we are using, and on other side, that particular module or that particular component or that particular service that we are using at the back end, or as an IT user, that would be available to us on the go. So the deployment time is very less uh, when we say when we adopt cloud computing. And um, how many companies are shifting to cloud? This slide would actually go on to explain you. Um, uh, you can see over here in this particular slide over here, this has been sourced from the Forbes. It is a top-notch company which prints a Forbes magazine also, which is a consultant to various technology companies, product companies worldwide. As you can see, in 2008, the market was close to 5.6 billion dollars, which went to $56.6 billion if you look over there carefully by the year 2015. So private cloud was there, unicorns were there, legacy software there, cloud revenue was there, public cloud was there. So these were various participants. So lot of action was there in public cloud as well as in the private cloud. And by year 2018, this would actually grow at a cumulative aggregate growth rate of 22.8% to $127.5 billion dollars. That is the estimate. So you can well imagine the size and the scale at which it is growing. Why it is happening like that? Because companies have suddenly they have come to know the advantages of adopting cloud computing. Companies, they as you can also, something I would put into perspective over here. There's a lot of talk these days of startup companies. Now these startup companies, they start in a very small office space with 5, 10, maybe 15 or 20 employees, with one or two promoters of the company, or sometimes even 5, 6 people who are actually starting a company, they are the promoters. So once they start these startup companies, these companies do not uh, go on and own the entire IT infrastructure, or they do not go on and own the entire platforms. They would simply ask some of these cloud service providers to provide them the tools and the technologies which are needed to run their day-to-day affairs. For example, let's say there is a company which wants to, which has deployed 3 of its engineers to develop a website in PHP. So they will ask the platform as a service provider to give them maybe 10 cores or 20 cores of PC. On top of that, maybe 3 virtual machines or 4 virtual machines, and on top of that, they will ask for a Linux operating system fitted, or you can say, which has got a component of Apache web services. Apache web server is there, and they will ask for MySQL services on that Linux box, and they will ask for PHP application development environment. Land C, you are on. They would actually give you connectivity. The cloud service provider would give you connectivity for this entire stack of service you have asked for, and the engineer would simply plug in into that system without actually owning it. So this is what we actually call as real-time deployment. So companies don't need to actually buy this entire piece. So, and they are available now to supply these 3 different virtual machines to 3 different engineers in their company, and they can now collaborate and they can do their tasks. So this is how companies are migrating. This is one very small example that I've given you. And companies, they do not want to have the storage inside their company, so they will simply go to certain infrastructure provider and they will ask please can you give me certain amount of storage in your they will go to a company like Rackspace or EMC Square or Google even or IBM, and they will ask that please give us, or they will go to Dell, please give us this much amount of space, we want to store our data in your data center, and the company will simply give them a link to where their data center is residing. Their data is residing in the data center, and they can simply use their data as and when they need. So that is how data centers business works. So and as you can see in this slide also, this is sourced by IDG. What they are saying that 61% people inside the industry, they actually agree that their organization is evaluating investments in the emerging technologies such as software defined networks and network virtualization as a way to get the most agility out of their cloud investment. So actually cloud has been put to use. It is, though it is still a work under progress, it is a maturing technology, but it has also gone on to the level of software defined networks and network virtualization. As we would try, if you try to make sense of this software defined networks, so what do we mean over here? That the network which is actually serving the, now we just imagine the network as a huge information highway where all the people are using the same network to converse. The same network is being used by various internet service providers, the same network is being used by the various banking companies. So there are multiple players which are actually, and telecom companies are the ones which are actually providing the network at the back end. So to utilize that network, even in that the cloud technology is now participating, so that the network is software defined. That is, the behavior of the network becomes software defined. We can actually go on to virtualize the network using network function virtualizations. So that is where this whole industry is heading to, and people are now going towards software defined networks. And so this is also one purpose of study when we actually take a computer science engineering course with a specialization in cloud computing and virtualization technology. So these are certain job titles that you would be actually going into once you have acquired one has acquired cloud computing specialization. These are certain job titles. You can read through those, or like the software engineer, Java engineer, system administrator, WebSphere cloud computing engineer, software developer, cloud developer, cloud consultant, cloud system engineer, cloud system architect is not mentioned over here. So these are certain cloud computing specialist job titles. These job titles are very much in demand these days when these cloud computing skills are advertised by various companies. Those companies would actually advertise those positions. So there would be certain entry level positions like software engineer, system engineer, Java engineer, network engineer. So these WebSphere cloud computing engineer or software developer, that is the roles via which you actually get into the industry. And if you have those cloud computing specializations, you actually go on to migrate as senior software engineer or a senior systems engineer or a system administrator or a project manager or a cloud systems administrator. So you can see on the left side these are the certain entry level, and then at the advanced level are given on the second column in this table, starting from hosting sales to the cloud systems engineer. So these are certain job titles that you normally look at while you graduate out of these programs, and we definitely hit some of these job titles when we do our recruiting here at UPES and at the various recruiter companies. I would actually if you ask me, I would need 3 or 4 slides to put the list of all the recruiters which actually come and have a look at our CIT programs, which have already had look at our various CIT. When I say CIT Center for Information Technology programs over last close to 4 years, so that is there. But you can definitely have a look at these current list. These recruiters have been visiting us recently, and these are various top-notch companies like there is Dell, IBM, which is visiting, and then there are certain companies like Applied Information Sciences, ATOS, Evon Technologies, and there is Terramatrix and Nagaro, Zensar, Zebia IT Architects India Private Limited. So these are various companies which are actually which have shown particular interest, and there are certain other companies also which actually come and have a look at our cloud computing students. And depending upon their needs, of course, there has to be a need in the company to recruit a particular skill set, and then they go on and recruit our students. So that is about the various recruiters which are visiting University of Petroleum and Energy Studies. And with this, I will now close my presentation since I've been speaking now close to 1 hour. So lots of things I have said, and I guess to those people who are actually listening, there must be certain queries. As I can see, there are certain queries which are getting displayed on the terminal besides me. So for next 5 to 10 minutes, I'll be taking your queries. We can go even beyond 10 minutes. So if there are more queries, we can definitely handle your queries. So I would request you to please start typing in your queries. If you got any query pertaining to certain portion of the presentation that I have made, you can refer to that. Or if you got certain general query, you are most welcome to give that to me. I'll be most happily answering those. Yeah, over to you now. Okay. Hi Akash, we have seen your query. Akash Gupta, he is one amongst our audience. Thank you, Akash, for that question. His question is that does cloud computing work for online cab aggregators? Definitely yes. Definitely yes, Akash. It is a very intelligent question and good that you are asking it. I guess you must be belonging to somewhere in National Capital Region. That is where Olas and Ubers they are high in action these days. And with that odd even formula that we had recently, those people were really in vogue at that time. So, Akash, I would explain it like this: that these online cab companies they actually place a GPS enabled device in all the vehicles which are registered with their services, which have actually gone on and taken a license from these companies. So once these cars they actually come on the road, these vehicles would start emitting signals, their GPS would be turned on, and their location would be tracked. So once this GPS signal gets tracked, now the companies would know that these many, let's say Hotel Ashoka, or let's say some fast food giant, McDonald's in Connaught Place. So that is where there is more likelihood of people calling in cabs, or railway station. That is one more example, ISBT. So those are places where people would be actually calling in for more cabs. So they will now fix the routes of the various people who are actually not in those areas, so that more cabs can converge into these centralized districts, and there are lesser number of cabs which are available. So a real time monitoring would be done to fix the routes of these to fix the routes of these cars, to do their route tracking, whether they are following the shortest route, the driver is not fleecing the user. And yes, a huge cloud computing backbone is working at the back end of it, because um, if you ask me, on a Saturday evening, there will be more people who will actually coming into the system, who will be pressing that app because they want to go out for a party or maybe to a get together. There will be more consumers of those cab solutions. So you need a scalable solution. you need a GIS backbone at the end of it, and you need a high performance computing which actually manages those cabs in such a manner that more number of cabs are available at those places where more demand is going to come in, or where there is more demand, there is a possibility of more demand which is going to come in. So that is how we perceive it. Okay. Uh, so the next question over here, I don't get the name over there. It is, does cloud computing also include application development? See, any computer science engineering program over here in UPS would have a strong component of application development, because if you look at carefully at the industry that we have in India, it is more inclined towards application development. And what do we mean by application development over here? Application development is that we want to actually build a piece of software using various other software creation tools. So yes, in cloud computing specialization course, there is a huge element of application development, and we do give a lot of emphasis here at UPS to software coding skills, because that is a must, or it is a very very important component when you actually graduate and you go into the industry and you assume a role of an engineer over there. You would be essentially be deployed in, there might be certain consulting roles which are available in the industry, but even to be a very good consultant or to be a very good architect or solution provider, you have to be really really good in your coding skills. And yes, definitely yes, we do lay a lot of emphasis on coding skills. Yes, cloud computing is very much about application development as well. It is very much about that also. Hybrid cloud, it was answered. Hybrid cloud, it was answered. I could read that while the presentation was being made. So, any more queries from your side, friends? I would encourage you, if you are still listening, you can still send in your questions. We are sitting here to answer those questions. Welcome. Okay, the question here is, tell more about cloud computing. Okay, what I'll do now, that I'll be telling you how we actually, what are the various areas of study that you take while you pursue this program over here at University of Petroleum and Energy Studies. Uh, there are certain subjects which are pertaining to cloud computing domain, where we would be actually telling you about the open source softwares and open source standards. We'll be telling you about the virtualization technologies. We'll be giving you a hands-on skill on virtualization technologies, where we will actually go on to understand the various virtualization tools like KVM and XAN and VMware. Uh, just to give you a brief, see, there are two different categories of virtualization tools. One category of virtualization tools is called type 1 and another one is called type 2. Now, there is one set of tools which is very close to virtualization technologies. When we say close, they are, in fact, if you ask me, they are in between the operating system that we have on the machine and the hardware we have. So we deploy those virtualization softwares on the top of those. So those are like your XCN and KVM. And then there are certain other type 2 virtualization tools which actually are riding on the top of a host operating system. For example, if you're using a PC at your home or a laptop, now on that you will be using most probably a Windows operating system or a Linux operating system. So that operating system by which you are able to utilize that would be classified as a host operating system. So now I'm actually talking about a virtualization layer between that Windows and the actual hardware that you have at your disposal. And another piece of type 2 type would be the virtualization software that you actually go on to deploy on the top of your Windows or a Linux operating system that you are using in your day-to-day life. Once you have actually deployed this type 2 software, then you do what? Then you have to actually supply it with the operating system image. So that virtualization software would be actually given the service would be actually supplied with the operating system image that might very well be again a Linux or a Windows. So it is like you have a hardware, and on the top of that you have your Windows operating system. On the top of that you have your VMware virtualization layer, and then on the top of that you install a Linux machine. So that is another thing. And um, then other subjects are like cloud computing reference architecture, and there are certain other subjects like cloud application development, where you would be doing that in your Java courses. And then there are certain databases like DB2 and Oracle that you will be studying. And then finally cloud performance tuning and cloud security. So this is how we actually deal with the cloud computing course here at University of Petroleum and Energy Studies. So um, so we take this question by Priyank Bhandari. Okay. So there is this question by Mr. Pratyaksh Bhandari. In fact, it's not a question. He's just put in a comment and then he's followed up with a question that there is certain Mr. Nitin Khanpurkar who has said that since India does not have ready talent pool, they might command a premium. Um, Nitin, I'll tell you one thing. See, there are various pathways when you actually, no, sorry, not Nitin, Pratyaksh. There are different pathways by which you enter into an industry. Um, industry when you actually enter, they are looking for a entry level graduate engineer who is willing to learn and who is adaptable to the company norms and conditions in which other people are working over there. So once you have actually landed your company, lots of dynamics actually happen over there. And with regards to security of the job, um, I mean, to speak least, I mean, there is no security while we actually traveling on the road. So, security of job is something that we as a university we cannot actually guarantee. But this is definitely one promise which we as faculties we definitely make to our students, that if you have actually taken all the things which have been done, which have been put to you, which have been given to you inside this 4 years course, you have do them seriously, then more often than not you will be actually having a rewarding career. That is what all I can say. That is a generalist statement that somebody has made, and there is IT industries, in fact, if you ask me, plagued by attrition. So once a person gets skilled, he leaves that company where he has actually acquired that skill. So if you graduate from this program from here, let's say from UPES, you would be definitely in a much better position. I would rank our graduates with close to 2 to 3 years of working experience once they come out of these courses, because that is a level to which we actually take our students. So that's all. I mean, to put end to that conversation, that what is about this security of job. Thank you. Thanks for that comment. Okay, so thanks everyone for joining. Thanks for listening to and putting your queries. We really appreciate